This question's about excitation energies and the energy levels within atoms. Um, and we've got the collision of an electron. So collision of an electron is one way that an atom's electrons can become excited from the ground state. So that's what we're told here. Because they're electrons and not photons, they don't have to give up all of their kinetic energy within the collision. So the electron could collide and only give up part of its energy within the collision. So it can give up part of its kinetic energy. If it was a photon, then the photon is either absorbed or it is not. So if it's a photon, the restrictions are a bit closer in terms of what it is permitted to do and the energy transitions which are available. An electron with 13 electron volts. So we have the ground state of negative 13.6 electron volts. So this looks like hydrogen to me. And then we've got a level at 1, we've got a level at 2, we've got a level at 3 and a level at 4. And we've got each of these higher values. Remember that going less negative are actually higher values. These are higher energy states. So we've got these values in here, and we have 13 electron volts available. So 13 electron volts available. If the electron were to collide and give up all of its energy, then that would get us to a level of negative 0.6 eV. Now, that is not enough to get up to this fourth level. So level 4, from that sort of collision with that energy of electron, the electron cannot give any more energy than its total kinetic energy, so it cannot get up to level 4. In theory, it can get to, it could collide and only lose part of its energy, so in theory, it could be promoted to level 1, in theory, it could be promoted to level 2, and in theory, it could be promoted to level 3. But that doesn't actually matter. All we actually need to work out is what's the highest energy level that it can be promoted to. So the question is asking number of wavelengths of electromagnetic radiation available. Then we only ever have to go to the highest one, because you could worry, well, it might go to 1 and then go down and there's 1, or it could go to 2 and it could go from 2 to ground, or 2 to 1 and that's another 2, or it can go 3. But if it can go to 3, it can go from 3 to ground, it can go from 3 to 2, and then from 2 it can go from 2 to 1 or 2 to ground anyway. And once it's at the energy level of 1, it can drop to ground. So actually, by going to the 3 level, you get all of the possible transitions you would have at 2 and all of the possible transitions you'd have at 1 anyway. So you only need to consider 3, but make sure you consider all the possible transitions. So from 1 to ground, there's only 1. From 2 to ground, there's 1, 2. So that's 3 in total. And then from 3, there's an additional 1, 2, 3. So you go up to 6. So there are 6 possible transitions. So let's see if I've got them all here. So we've got from 3 to 2. I haven't got 3 to 1. So 3 to ground, 3 to 2, 3 to 1, 2 to ground, 2 to 1, and then 1 to ground. That's all 6 available.